What's cool about this is that we're discovering all these exoplanets that we didn't really anticipate either could exist or like would exist, right? We found a lot of exoplanets that are like so close to their stars that they're totally molten planets. They're just like lava planets. Whoa. Think about like Shark Boy and Lava Girl, right? There's like we have gas giants in our solar system, and they only exist because they're so big that the gas actually has gravity, right? Yep. But we found like water worlds and molten lava worlds, and we have found these special kind of planets called super puffs.
Oh God!
Can you guess what that would be made of?
Super puffs.
We already said gas. We already said water. We already said lava. Molten whatever. What would be left?
I'm picturing like a extremely low density gas giant.
Yeah.
But then there's these really weird low density planets that have densities like styrofoam and cotton candy. One thing to think about is if you have something that is so low density, then it needs a lot of gas essentially to be part of the planet, because gas is the lowest density thing that we can think of. But based on our understanding of planet formation, it's hard for a planet to just have that much gas, but also a low mass, which is all of these. Most of these superpuffs also have very low masses. And so if you have low mass, then it's hard to just attract all these gas to you and make yourself very puffy. At the same time, it's easy to lose this gas when it's heated up by the central star, for example. And so some of these planets shouldn't even exist based on our understanding of how fast atmosphere can just get lost into space.
So on some of these, we're guessing like, oh, maybe they have like an iron core, but then like the rest of it is gas, you know? Like if you look at Jupiter, it does have a core, but it's just very small compared to like the rest of the planet. Mm-hmm. So there are all these planets that we don't even really think should exist based on our understanding of physics.
Wild. It's kind of like how we find a new species on Earth every day. It's kind of crazy how many new species of animals that you discover. You're just like, what? It's a fish with feet on its head and an upside down stomach. Like, what is this? And we're just finding all these planets that we've never even thought would exist. But of course they do. Of course they do.
Yeah.
All I really want to know is when are we going to find life on one of these random planets? Because that's what we're after, isn't it? That's like the big picture. Like, are we alone in the universe type questions?
Yeah.
Where every place we look, we're like, well, could it hold life?
Yeah.
What's it made of? Does it support life? Is it the right temperature? Is it the right makeup?
Yeah. I mean, that's what's cool about the spectroscopy thing is we can understand like, okay, we know what supports life here on Earth. So if you get a similar thing, if you know that a planet is made up of water and it also has hydrogen and nitrogen,
we love that.
We could get,
we love that.
But we have discovered exoplanets before that people are like, oh, this could be Earth 2.0, but then someone else debunks it. And they equated it to sort of like cybersecurity, right? Where someone will put something out and then someone goes out to try to debunk that thing they just proved.
Right.
And this has happened over and over again where they think they found like Earth 2.0 and then someone else just went and they're like, oh, actually, like that element got masked as oxygen because of this like random other thing.
Wow.
And it's kind of sad, but
there's also an interesting element of curiosity about whether our assumptions about what harbors life are accurate or not. Mm-hmm. Like carbon-based life, maybe it doesn't have to be Earth-like to support life. Mm-hmm. Maybe it could be, maybe Jupiter and another solar system is like the most lively place in the universe. Who knows?
Right. And the fact that we've discovered like 5,000 exoplanets.
Yeah, something out there.
And then they've extrapolated this and they're basically like, there are too many to count. Like there's so many and we're just doing our best to like study as many as we can.
Yeah.
So yeah, we can study these planets to a very specific degree as a reference for how sensitive the JWST is. It can see the energy from a bumblebee on the moon.
Wait.
That's wild.
Wait, so hold on a second.
Yeah.
So the moon, remind me.
Moon is 250,000 miles away.
So it can measure. So let's say you point the James Webb Space Telescope at the moon. Mm-hmm. You're picking up all the energy and the spectrometer of the moon's signature.
Yeah.
You put a bee on the moon, it can see that something passed in front of the moon.
It can basically see the bee.
Holy smokes. Okay.
Yeah.
This stuff is good.
And not from like a
good
like a
stuff.
telescope kind of thing, but it can detect the signature of the bee.
And we can do all this, but we can't get printers to just plug and play.
Yeah.
This is
Or stay on Wi-Fi.
billion-dollar
crazy.
industry.
I mean, but you also
it
kind of
does
talked
take a
about
lot
the
of money.
sea before. Like, we're doing this on exoplanets and whatever,
Yeah.
and we still don't know like the bottom of the deep sea. In our
That's
own
true.
planet.
Yeah, that's true.
It's wild.
there's so much pressure, right?
Let's just point JWST
at the
the ocean.
at the bottom of the ocean. It is in space. It might as well point it down at us. I don't know what
the
it'll
problem
find.
is light gets
Hey,
refracted.
but you're
That's true.
saying that we can, since we pay taxes, we're allowed to suggest it, right?
you could probably suggest it.
Formally suggest, point it at me from up there.
Let me get one of their
I wanna
numbers
see
that
it.
you interviewed here.
Yeah.
Yeah.
So like it's very cool. It's like I think of all the people that I interviewed, what they all said was probably the most exciting thing about James Webb is that we don't really know yet what we're going to discover.
I love that.
Like there's parts of astronomy that just keep getting discovered year after year. Something that Jonathan McDowell said was like,
This is one of the great things about astronomy, right? For me, is in my career, I've seen fundamental philosophical questions that humans have had for millennia answered. Okay, next question, right? So, how old is the universe, right? People have been answering that. Okay, as of, the 1990s, we now know 13.7 plus or minus 0.1 billion years. Next question, right? And then multiplicity of worlds that Giordano Bruno got burnt at the stake for, right? In the 1600s, like, is Earth the only world, or are worlds common in the universe? Yep, they're common. Next question. And so, it's that is for me the amazing thing, that we can take these things that are not just, what, like, nerdy, what's the temperature of this gas cloud there, but they're like these, which I love, but there are these deep questions that people have wondered about for thousands of years, and we can definitively answer them. And that is the age we're living in. And that's why we put so much effort into things like Webb.
It's cool because you're saying we've discovered these things that are so minuscule. This is going to help us extrapolate way more data from that. But then in the future, what are the minuscule things JWST is going to be seeing that we're going to build the next telescope to get closer to that? And how far is that going to go? Like in history, they're going to be talking about this, about it could barely see anything. Look what we're seeing now.
Totally.
It's crazy.
Yeah, and there's so many other things, like it's going to be studying like quasars and the way that like energy gets spewed out of black holes. And, it was only recently that we even really confirmed that black holes exist.
Yeah, true.
And now we're like just going crazy
like
on studying them.
different types of black holes. Yeah, this probably doesn't mean anything to anybody, but I'm like super torn on like what's the most important thing for humanity. And some people will say understanding the Earth and like as much about the Earth as possible. I think I tweeted a while ago, like we understand more about the surface of Mars than the bottom of our own ocean. Like we have a lot to learn about Earth.
Yeah.
But at the same time, it feels like it should be learning about the universe and learning about why, we're here in the middle of this like cold rock, in the middle of this empty expanse, but like how much can we learn about the origins of how we got here and like what we're made of, and are we unique to this part of the universe or what other stuff is going on out there? I think that's the most interesting.
Yeah.
Significant stuff humanity can do.
Yeah.
So like, this telescope, it's pretty sick.
Yeah.
It's pretty sick.
And it is cool because like a lot of people have made the, joke like, oh, we're going to find aliens. We're going to find aliens.
I hope so.
But like with so many exoplanets existing, we know that there are so many out there. There is some level of probability that there is life. It's just, obviously they probably won't be humans, but probably somewhere an exponential amount of distance and light years away, there probably is humans or something like that, right? Like if there are infinite universes, there are infinite possibilities, we'll see
Metaverse theory.
We'll hopefully see something twice, right?
Well, if you enjoyed watching that clip, definitely watch and listen to, if you can, the entire James Webb Space Telescope episode. It's a deep dive. It's a long one, but there's way more crazy engineering, crazy facts, unbelievable stats about the universe and this engineering that went into it. So for sure, check that out. But if you're just going to hang out here on the Clips channel, might as well subscribe. Might as well hit the red button while you're here.
Just like you shift the light. You can
Shift that button.
that cursor to the red
To
button.
the exact. See, you
Thanks.
put it better than I could have.
Thank you.
See you later.